Hello, this is Ellie from the Math Center. And today we're going to be talking about implicit differentiation. So to start off, we're going to realize that y is a function of x, and we're going to look at it as y. So if we wanted to take the derivative dx of y, this would be equal to dy dx, because we're taking the x derivative, which is the variable that is inside the function of y. Similarly, if we're going to be looking at a function such as r of x, which we're going to represent just as r, and we want to take the derivative with respect to x of r, this would be exactly the same thing, dr dx. So even if the function name changes, you can still do the same operation. So let's see how this is helpful in implicit differentiation by setting up an example. In our example, we're going to have cosine of xy is equal to e to the x plus y. So to do implicit differentiation, we're going to take the derivative with respect to x of both sides. So we're trying to find dy dx. So here we have d dx of cosine xy. And we're going to set that equal to d dx of e to the x plus y. So first thing we're going to do here is take the derivative with respect to x of the left side. So cosine of xy, we're going to have to apply both the chain rule and then the product rule for the inside. So the derivative of the outside function, cosine of something, is going to be negative sine of what's inside, xy. Then we're going to multiply this by the derivative of the inside. And here we're using the product rule. So first we're going to take the first term, multiply it by the derivative of the second term. The derivative of y with respect to x is dy dx, as we see up here. Then we're going to add the second term times the derivative of the first term, dx dx, because x is also a function of x. But the change in x over the change in x is always going to be 1. So we can just write a 1 there. Now let's move on to the right side of the equation. The derivative of e to the anything is e to that same thing. And now applying the chain rule, we're going to take the derivative of the inside here. So first the derivative of x with respect to x is the same thing as over here, 1, plus the derivative of y with respect to x is going to be dy dx. Now we're looking for dy dx, so we have to put everything with the dy dx over to the left side and everything without onto the right side so that we can factor out a dy dx. So let's go through that process. First, we're going to expand everything. We're going to get a negative x sine xy dy dx minus y sine xy. Now on the right side, we're going to get e to the x plus y plus e to the x plus y dy dx. Now let's move this term to the left side and this term to the right side. So we get negative x sine x plus y, xy, there we go, dy dx. Moving this term over to this side, we get minus e to the x plus y dy dx. So now on the right side, we have the e to the x plus y, and adding this term over, we get plus y sine of xy. Here we have a dy dx in both of these terms. We can factor that out and get dy dx of negative x sine xy minus e to the x plus y. This is equal to e to the x plus y plus y sine of xy. To isolate dy dx, we divide both sides by negative x sine xy minus e to the x plus y. And do this to this side as well. So in the end, this will be our answer, or dy dx is equal to e to the x plus y plus sine of xy times y over negative 1 that we can factor out of the bottom section here times x sine xy minus e to the x plus y. I hope this helped with implicit differentiation, and we'll see you at the Math Center.